question 5. So we know the sum of the first two terms is 34. Well, the first term is a, and the second term is a times r. So the sum of the first two is a plus ar, and we know that equals 34. We also know the sum to infinity is 162. Now this is the sum to infinity, that's given in the tables. So the sum to infinity, 162, equals a over 1 minus r. So we've generated a simultaneous equation. We've got two equations and two unknowns, a and r. So we just need to solve these by substitution. So what have I done? I've taken 2 and I've chosen to multiply. I've called them 1 and 2. I've taken the second one and I've chosen to multiply both sides by 1 minus r. So I've got 162 times 1 minus r equals a. And I've then just multiplied out the bracket to give me this equation, which I'm calling equation 3, and I've substituted that into equation 1. So I've replaced a with 162 minus 162r, then plus a again, 162 minus 162r times r. So I've then multiplied out the bracket, so this gives me 162r minus 162r squared. So we're left with this equaling 34, of course. So these two 162r's cancel out, so we're left with 162r squared equals 162 minus 162r squared equals 34. Now I've added 162r squared to both sides and take away 34 from both sides to get 162r squared equals 128. I've then divided by 162 and halved it, and then not halved it. I've simplified the top and simplified the bottom by dividing by 2, both top and bottom, giving me this. So that's what r squared is. So square rooting, we get r being 8 over 9. And then for part B, where I need to work out the first term, well, that's easy enough. I've just picked up my equation 2, where I know that a equals 162 times 1 minus r. I've just worked out r to be 8 over 9, allowing me to work out a to be 18. Now part 2, a different geometric series has a first term of 42 and a common ratio of 67. So a equals 42, r equals 6 over 7, and I need to find the smallest value of n for which the sum of the first n terms exceeds 290. So using this formula here, I know that 42 minus multiplied by 1 minus 6 over 7 to the power of n, close bracket, all over 1 minus 6 over 7, it's got to be greater than 290. So I have then, this is a 7th on the denominator, so I've chosen to multiply both sides by 7 and divide by 42, giving me 1 minus 6 over 7n being greater than 145 over 147. I've then added this to both sides, deducted this from both sides, so this is now over on the right, so I've now got 6 over 7 to the power of n being less than 2 over 147. I now bring logs into play, so n times log 6 over 7 is less than log 2 over 147. I then divide through both sides by log 6 over 7. Now have a care, log 6 over 7 is negative. When we divide by a negative, it changes our inequality sign. So now n is greater than log 2 over 147 over log 6 over 7. Pop this into our calculator, we get n being greater than 27.87, so n equals 28.